Yeah, we always say those two words together in Chinese.
What's the Phoenix?
It's like the king in China represent the dragon, and then the queen represent the phoenix. It's like on their clothes.
Phoenix is like the one in Egypt, right?
Yeah.
So it's like a male female thing?
Yes, like phoenix is more like a represent like female, like those kind of feeling.
Why did you personally identify with Phoenix all those years?
No, I thought this is like in Harry Potter and stuff. Phoenix, they're like animal.
Yeah.
Okay. That's
What's the Egypt associated with it? In Egypt, you find like an animal that sits.
Sphinx.
The Sphinx.
Why is that relevant?
Hey Derek, can you see the
On
screen?
the topic of mythical animals. What's this?
Not yet.
So it's still loading?
Yes, I can see it now.
Okay. So originally it's called Functional Programming 101, and then I realized everyone's 101, and then I changed it to Intro to Functional Programming, and then I realized the scope is too big. So the main agenda for this sharing session is to talk about a few key principles in functional programming. So here's the agenda. So the first part is the scope, and in the scope, I will mention those things that I won't talk about, but definitely would be something that will be in the maybe next sharing section, so we can keep our discussion focused. So I will not talk about a specific functional programming language like Scala or Haskell, just to keep things simple. So when you explain a principle as well as the syntax, it's kind of a lot of overhead. So try to use Python to explain those principles, which is a language that we already learned. And also for the first one, the functional programming language, this not like strictly speaking, there's not something as like a functional programming language, because you can apply this principle to any language, but because each language is designed based on different like style, so it's like easier to use functional programming in, let's say, Scala, but very difficult in Java. So just keep that in mind. But this is something that we are not going to talk about in this section. So the first question that we want to ask is like, what is functional programming? So this is the definition from Wikipedia. So in my mind, functional programming is just a paradigm that has something to do with math, and that's how I interpreted it. So a paradigm is like a style that you would write program. So similar to functional programming, other paradigm include imperative. So example would be if you want to calculate the sum of an array, then you would add this array one by one by telling the computer, okay, first add the first element to the array, next add the second element to the array. So that's what we call imperative. So declarative is something that you would describe the result that you want instead of telling the computer directly which step should be done to reach that step. So one very famous example is SQL query. So the database would take care of specifically which step to do to get the result, but you're just telling the computer what you want by saying select something from somewhere where blah blah blah. And object-oriented is familiar to all of you guys, so I won't repeat. And also functional programming is something that we would discuss today. So before I was learning that, I used to think that functional programming is exclusive with object-oriented programming. And that's what I was taught in school. So either you are on this team, on this team. So these two cannot work with each other. But it turned out it's not the case. So you can use multiple paradigms in the same application. And you might heard of a language called Scala. So the reason why the inventor invented Scala is he wanted to do a academic experiment to see whether object-oriented programming paradigm can work with functional paradigm. That's one of the attempt of the experiment. So before that, there's also other language to test this hypothesis. But the success of Scala proved that OOP can actually work well with functional programming. Any question so far? Okay, so there's a lot of principle actually because there's no one ever like strictly define what functional programming mean. So there's like a lot of opinion on this topic. So I watched a few video, a few talk, and then here's something that most people would say when they talk about functional programming. So we will cover 4 of them in this sharing section. So the first one would be treat computation as evaluation of mass function. So this is very different from object-oriented programming. So in object-oriented programming, we are encapsulated a collection of data that's related to each other into a class. And then this class would be responsible for doing something with this data. So you can treat it as there's a lot of class that's sending message with each other, and all of them know their responsibility that they're doing something with the data. But for functional programming, you need to think about more from a math perspective. So when you're learning math in high school, like a function basically is like a mapping. So it's map some input to some output. So the for example, a simple function would be y equals x. So it would just be a line. Or this, we can have like a absolute function here. So like each value here, like 0 will map to 0, 1 will map to 1, and then -1 will map to 1. So you need to think of the problem like, so when you wrote some code using the functional programming paradigm, the first step you do, you try to think of how you would represent the problem using some mathematic function. And then you try to fix the problem in that way. So because of the way how functional programming like decompose the problem, there's a few patterns that functional programming would prefer. So first is that functional programming would prefer expression over statement. So statement would be something like an assignment, that you are assigning 42 to x. So this is, let's see. So this is what we call statement, like we're returning something, or it can be something like if value less than 0, then we will say, okay, the result equal to minus val, or it can be result equals to val, and then we return it. So that's what we call statement. And functional programming would prefer expression. So this whole thing is an expression. So when you reading the code in Python, it does not make much difference because Python is a multi paradigm language, so you can do both ways. But let's say you are writing the code in Haskell. So Haskell does not allow you to do it in this way. Like in Haskell, there's no statement. Like you can just express a function using expression. So like we start worrying about the syntax. The way how Haskell define a function is very similar to what you would do when you define like a mathematical function. So when you define a mathematical function, like this on the whiteboard. So when you define the absolute function, it would be something like this. X 0 minus 6. So it would be something like this. So basically, I'm not sure how to show it to there. So basically, when you wrote in Pascal, those syntax is very similar to how you would roll like a mathematical function in like an essay or paper. And in a pure functional programming language, you cannot use statements. So it forces you to think every problem in terms of like expression. So another characteristic is that because functional programming is so different from iterative programming. So iterative programming, he would tell you for each step what you would do. So in imperative programming, that loop is preferable because the loop will tell the computer exactly what it needs to do. But in functional programming, we need to define using some mathematical function. And it's very difficult to define something in math using loop. So if we use, let's say with that, we want to roll a function called sum. So the imperative style would use iteration. So we're just like adding a number to a variable, like step by step. So we define every step.
So does that count as functional programming still, but because it's still a function?
Yeah, it's still a function.
So it doesn't count as a functional programming.
So it's not true that as long as the row function is functional programming, otherwise that the bar is very low. Yeah. So it's not the case that if you roll object-oriented programming, you need to adhere to some fundamental principle, like you need to encapsulate data. So it's very similar in that case.
So what's the idea behind the first example?
The first example is that this.
We wouldn't prefer that as part of functional programming, but still it can be considered functional.
No.
So that's what you're saying.
No. So functional programming is that instead of trying to tell the computer exactly how to do, you are telling what's the mapping, like how do you map a data to another data.
I think in the first example you keep track of the state. In the second example you don't keep track of state.
No. I understood what each example does and what fundamental features. Do we call it functional programming, or is it preferable to call it functional programming the first way? Or
The first way we would.
It's a functional programming, or it's not ideal to call it functional programming?
It's not ideal. We would say the first way the program is using the imperative programming paradigm. In the second case, we said that it is using the functional programming paradigm. But of course, in Python, this way is not very efficient because it's creating an array. But you get the idea. So it's like trying to avoid iteration is using a recursion kind of a call. And if you are doing this in Haskell, so in Haskell it does not have an array natively, but it has a list. The list is more like a linked list. So one of the feature Haskell has is that you can, based on the input, and do different things. So for example, this is the mapping I'm talking about. So if the input is an empty array, then it will map to 0. If this is an array that has one element with another list, you will map to the first element at recursively calling sum on the rest of the array. So it's solving the problem by creating a mapping. So,
Sum 2
or sum. I forgot to change this. So it's like mapping an empty array to a 0 and mapping a non-empty array to the first element at the recursive call on the rest of the array. So that's the mapping. So it's like when you are using functional programming paradigm, even though in some language you might still write the same. It's possible that you still write the same code as you are using different paradigm, but the underlying reason will be different. But this is more obvious when you're using a pure functional programming language. Just don't worry about syntax. The most important thing is that the mapping. here.
Yeah, so you're confused by the x colon xs.
Yeah.
So that's basically doing what it's doing is it's getting x as the last element of that list, and x rest of the list, and separating. Sorry, x is like the first element of the last list, and then xs is the rest of the list. Right?
Oh, so those are already like predefined variables.
No. So the colon notation, the colon notation is extracting one element out of
One element
I think
at a time.
this is very similar to
It's like one element at a time, right?
No. So it's like think of it as a for each loop, right? For x in x's, for number in numbers, right? You're taking
Yeah. So that's why Coach I said
froze.
for x in
My iPad froze.
for x in for
array in array list, something like
yeah kind of. It's
So in Python, there's a way
that.
to
Biscuit in this case.
kind of. It's not really like that. It's a common notation in functional programming, and it's just
Like a list operator.
yeah, basically.
So in Python that you can unpack a tuple by using this. So it's like you define two variable a and b, and then there's the data somewhere, and then Python magically know the one will go to a and two will go to b. So if you have a list, so Haskell is very smart. You notice a list. This is a special notation, just like a comma b. So he will unpack the data and put the head of the list to x and the tail to xs. This is the way. So this is called pattern matching in functional programming. But it turned out to be very useful because we're doing the mapping all the time. So the pattern matching is a very common technique in Haskell. So this is the most simple example I can think of. Don't worry about the syntax. So the second principle is that, this asks a very good question. Is it true that as long as we use a function, that is functional programming, and as it's not, then we need to use pure function? So the definition of pure function is that it satisfies two requirements. One is that the function cannot have side effect. And the second is that the same input should always result in the same output. To give you an example, so what do we mean by no side effect? I have a typo there, side effect. So can you guys guess what do we mean by side effect? So I'm waiting for more answer to continue.
You're counting and you're deleting.
Yep. So the very strict definition of side effect is that anything is observable from the outside. So if the function is a black box, anything observable from the outside will be considered a side effect. So a very common example would be something like you're printing something, so you're affecting the standard output. Or you are writing to a file, you're affecting a file on the disk. Or you are mutating the input. So those things, all of them cause changes that can be observed from the outside.
Those are all not functions, not pure functions.
Not pure function. Yes.
Do you know how functional paradigm, how do they do the I/O stuff?
Yes. We'll talk briefly talk about that.
What the sort, even the sort?
Yeah. So
What's the observable change?
that sort happen to be an in-place sort. So it's not sorting by creating a new array. So there's another function in Python that would be considered pure, which is sorted. So for example,
No. So, like, before going to this,
yes,
are these pure functions or not pure functions?
this is not pure function.
So the insert should be a pure
In
function.
place sort
Should be a
effect is changing. Right? So you input in an array, right? And that array gets changed because it's an in place sort. Right? So if you looked at nuns again, you'd be a sorted version. Right? In purely functional programming, stay the same.
Oh, I see. Oh, I see.
So a pure function, one of the requirements that it cannot have side effect. Here's the example that has side effect. It's like a counter example.
Impure functions.
So let's go to Fahn's question. Like if an application is writing using functional programming and all of its functions pure, then it means that this app cannot change the world in any way. Like it's pretty useless. Like how does functional programming handle this? And then I find this answer. So basically, you can take a look at this answer. And I think the takeaway is that in functional, if we're writing application, the application need to generate side effect. But what functional programming suggests is that we limit the code that is not pure to the minimum. So it's like, for example, what I visualize this thing is that let's assume you got a spaceship. In a spaceship, it's very pure. Otherwise, human cannot breathe. And the universe is very dirty. And a human cannot survive there. And when an astronaut come from the universe back to the spaceship, they would enter like a tunnel. They would clean themselves, and they would like make sure there's no jam going back to the spaceship. So that's what I imagine what the functional programming application will do. Is that the majority of the code is pure. They only limit a very, very small piece, maybe like 1% of them would be communicate with the world, like generating output, taking input, or writing data somewhere. So in functional programming, there's a concept called monad. So M-O-N-A-D. And M-O-N-A-D is this.
Actually going to explain some stuff. So tonight I'm talking about monads.
So this
Monads
is,
is something that was popularized by the Haskell community and has started to infiltrate its way into other language communities, including ours. And it's a really interesting thing and really powerful thing, but it seems impossible to understand because in addition to its being good and useful, it's also cursed. And the curse of the monad is that once you get the epiphany, once you understand, oh, that's what it is, you lose the ability to explain it to anybody else.
That's basically what it is. So,
To understand what it is, you will explain that.
so monad basically is one of the most complicated example of concept in functional programming, but it's also the most important feature in functional programming because all those things that would generate a side effect would be done through monad. So for example, when we're learning a new programming language, the first code that we wrote is hello world. So the hello world will generate output, which generates side effects. So in functional programming, it's done through a thing called monad. But you cannot expect like a beginner to understand. I don't even understand like what's the monad is. I watched 5 videos. Like everyone is talking differently. It's indeed a curse. Like when you guess it, you lose the ability to explain it.
What's a goal?
What? I don't know.
Ball. Ball. Test once you
I
get
know, I
some
mean, like,
the
programming
context.
Yeah.
I think that's that was a joke.
This word is the last word.
No, it's been here for like a few decades.
For functional programming.
Yeah, for functional programming. It's invented by Haskell. And then Haskell was invented like 20 or 30 years ago, I believe. But it's been around for a while, and then it's introduced to the JavaScript world, Scala world. But it's like, in a nutshell, monad is the part that centralize all the code that need to generate side effect. That's my understanding towards monad right now.
So in one application,
Uh-huh.
you have a centralized position to
I'm not sure whether it's like the centralized position, whether it means the position of the file that wrote the code, or it's more like an abstract level of stuff. So it might be a data type that encapsulate all those logic that would generate side effect. But it might not necessarily be like you have a bunch of file and only one file have the ability to generate side effect. Or more like it's only when you define like a data type using some principle that Mona enforce that you can generate side effect. But that's my current understanding.
So side effect is done through Mona, but does Mona equals to side effect?
No.
So once we say
So
we use Mona, does it mean we absolutely have
No.
No.
So it's just one of the things that I do. If you are interested, you can take a look at the. You can give a try to see whether you can get it. I didn't get it.
If you've ever, have you ever heard of lambda calculus?
Yeah.
The way that lambda calculus represents integers is what Mona is.
Oh, okay. Because in Wikipedia, in the Wikipedia page that explain functional programming, it says that the mathematical foundation of functional programming is lambda calculus.
Do you know what like an integer is like? Lambda calculus. It's not. Right? They make it so that it's like it's a function that represents. Right? And they're basically mapping an integer, a solid into a function,
Yeah, that's
I read that part. I read how lambda calculus
also, if you're interested, you can on YouTube search why does functional programming matter, and then I think in the first few minutes, the speaker explained how we can decide a language that does not need Boolean. So it basically is that we can define Boolean as a function, and then it do and still achieve all the things that we need Boolean to do. Because we does not actually need Boolean itself. We need a way to make choice. So the Boolean is that we always like if true or false, and then do this or do that. So this is what we need. But Boolean is just a way to achieve this. So we can use function to also do this. And then after this, he explained what Eric said is how to use function to represent integer. And then it's become complicated, and then I stopped using it. But I haven't reached the phase yet.
understand calculus until I know how it represents this. Only remaining part is getting too complex and
Yeah, that's kind of complicated.
If you know lambda calculus well, function programming it's like lambda calculus turned into program. If you literally are writing lambda calculus, and it's
That's one of my toughest project in masters. So using lambda calculus, we created a function, like a programming language.
You created a programming language?
Yeah, I mean my professor was writing a programming language.
Uh-huh.
And he asked us each
For
of
fun?
our team. No, it's a course. So he asked us to like contributed to that programming language as an academic project. So as part of the project, each one of the team should choose one component. We chose functions.
Mm-hmm.
So we build functions using lambda. Liz is programming language name is called Waffle.
Waffle. Waffle. Interesting. Okay, so that's Monad. So hopefully I can also get it and explain it soon. So the second requirement for a pure function is that given the same input, we should always give the same output. So the counter example would be something like a function that this is just let's say, okay, hold on a second. So one of the counter example of not same input, same output is, let's assume some function that's relying on a global state. So let's say we, like in our code, that we have a bunch of code that's using some global variable. So assuming this function would change this global variable, then it's not pure. What I'm not sure is that if a function is relying on a global variable, but for some reason that we can ensure the global variable does not change ever, I'm not sure whether this edge cases would be considered as a pure function. But at least in this example, if it's relying on a global variable and the global variable get changed every time that's being called, that means that the same input would not generate the same output every time. So other example would be like date function, like date now, like every time we call it, like you don't have input, like generate different output. Also, like a random function will also be considered not pure.
Does it mean they don't functional program you cannot use those?
You can use though, but
It's
if
not
you,
beautiful.
yeah, it's not beautiful. Like they,
Think of this as a definition that how the function where a graph looks like this, it's not a function.
Yeah, I know these,
Mhm.
but the thing is,
How do you represent?
so I think the question would be, can we use functional programming paradigm to program software that solve the real world problem?
yes. So,
So how do you? Yeah. Go ahead.
Like, for example,
So-
software or something.
all those things that has randomness is
Mona.
monads. Yeah.
So
if it's not pure, it's Mona.
So like using a date function in functional programming is a mode. That's what it is.
Yeah.
Right?
Yes.
I wonder like what's the percentage of Mona usage in functional paradigm?
So one explanation for monad in one of the talk is that you can see monad as like a abstract data type. So in Java that has list, but list does not have implementation. It's just an abstract data type. We just define a list, a collection of methods and how these methods should behave. And underlying this abstract data type, there'll be linked list, there'll be array, there'll be array list. So monad is an abstract data type. It defines some behavior that you should follow. So one of those behaviors allow monad to handle all those like randomness thing or generating side effect stuff.
Yeah, I wonder in the functional paradigm application, what's the percentage of Mona and what's the percentage of pure function in the real application?
Well, I think you're trying to use functional programming to do the same thing and empirical,
Yeah.
and they're useful.
So you would not use that, like for example, if you want to model real world, you want to use
Yeah, like you won't use a functional programming language to build a website, right?
You could,
you could,
But it's just not.
but people do. There's companies do that. Yeah.
It's not a strength.
So just to give you some context, Facebook using Haskell to develop their spam detection architecture. This is very fast, and then because that problem itself is very complicated, it's very difficult to use object-oriented programming to do that, and it's very difficult to prove its correctness. But that's the strength of functional programming. So like you can mathematically prove its correctness.
I think once you can model a problem in math, then you can use this program to analyze it.
Yeah.
Like using a program to do the thing is not correct.
Like even though in other language, if you want to generate a random number, but if you give it the same seed, like you always generate the same output. So for that one is pure. So like when you're doing functional programming, you're very similar, right? So the core is pure. It's only when you call it, there might be some impure part there. So your application is still very pretty from the functional programming perspective, like very elegant solution. So other example would be like if we have a class that we are calling a method on the class, and then that method, the return of that method is depending not only on the input parameter, but also some internal state of that class. So it will also be a counterexample of not pure in this case. So our next principle is called higher order function. And Python also have this, Ruby has this, another more like fancy word is called functor. So basically higher order function is definitions that either the first one or the second one. So it either can take a function as an input or can return a function as an output. So let's see example for the first one. So the most famous high order function is the three blotters, like map, filter, and reduce. So here's some example for in Python. So the map is just apply a function to iterable, filter iterable, and reduce is reduce iterable into one number or maybe multiple, some data structure. So another example for a function that return a function as output that I actually wrote is something like this. The problem I try to solve is that so I get a list of directory, it's lib bin log, and I would want to generate this. So if you really want to use functional programming in Python, there's a built-in library called func2. And there's a method called partial. So what this partial do is that it would take a function and it would bind this function to a list of parameters. So initially, the join function takes two input, right? So you need to give in two input. So what this do is that it will create a new function that it will always call this function with this as the first parameters, and then the second parameter would be passed by func. So for example, if I call func bracket lib, it would instead call this thing with this data and the data passed directly to func. So you're generating a new function. Should I repeat? That's a little bit mind twisted.
So it's kind of like taking two parameters, but you know one parameter you want once, so you give it first,
Mm-hmm.
and later if you want to use this function, you just need to do that.
So this is very common in functional programming language. It's like because they prefer map or filter or reduce over iteration. So in a lot of time that you need somehow change a function in a way that you only take one input so that you can put in a map function. So for example, for this case, in Python, that's another way we can do it is to use lambda. So this is more readable in Python. But like in Haskell, there's no lambda function. So what we do instead is something like this. Like Haskell natively support this partial features. Like it's like a syntax sugar built inside Haskell. So it's less ugly than you writing in Python. But that's the idea. It's like you would take a function, take some data, and then combine it and generate a new function. And then you can reuse later. So another pretty common high-order function is called compose. Is that like in mathematics, sometimes you would say f bracket x, and then of this value, you would call another function called g. It's like you got a value, you apply function 1 first, and then you apply function 2 first. And then this might be a very common task that you just want to combine the f and g in a way. So, for example, in Python, you can roll a function called compose, and then you would take f and g as an argument, and then we return a new function. For example, if I want to do this, like I have a dir, then I want to first call expand user. So you expand this thing to my name, and then I want to absolute it, so you remove this thing. So let's say that I want to write a function that will always apply this two function. I just say compose and then put this two function together, and then I get a new one, and I can expand, call on the value.
Like, there are a lot of places in our course to use this.
Yeah. Well, of course, in a imperative, so Python is written in a very imperative and object-oriented way. So using functional programming in Python is not very elegant. You need to do a lot of extra code. But let's say you wrote this in Haskell. So assuming you already have two functions, and then you want to compose, then you would just use dot. So you don't route anything. So there's those things that there's a lot of feature that if a language is designed using certain paradigm, it's very easy to use those paradigms. Python is not designed based on functional programming paradigm. So if we really want to use functional programming in Python, then we need to do a lot of extra work. So it might end up not being very efficient. But I'll just use Python to serve as an example, as a general idea like what you would do in a functional programming language. So another principle is to avoid mutation. Well, let's say that we have an input is an array, it's 1, 2, 3, and then we want to apply a function and return 1, 2, 42. So example of mutation is that we directly change that value in place. And an example of no mutation is that we will just generate a new array and change that value based on the value that is not changed. But there will be a problem. So it means that if, let's say that we keep appending some value to an array, that means that each time that we append, there will be a new array. And then the O of space will grow exponentially. It's like it starts with an empty array, so empty array, and then we add 1, so we get an array with 1. And then we add 2, so we got another array, 1 and 2. So like keep growing. So the way, I think the way how they solve it is they use a special structure called persistent data structure. Haven't had time to look into that yet, but if you're interested, you can take a look at that. There's a paper called Ideal Hash Tree. Basically, it explains how we can avoid mutation in a very practical way. So it's still efficient. And then a guy read a paper and invented a language called Clojure based on that paper. Was that called Clojure? It's like CLOJURE, Clojure. I think when I was learning functional programming, one of the things I realized is that it really encourage you to think of how you map some input to some output instead of thinking the data structure stuff. It's like when we're learning algorithm that we spend a lot of time to think algorithm like in a very imperative way, like the binary tree problem that we discussed yesterday. It's like get all those points here, like moving around to those just the focus. Well, that's why I was taking a course last year on Coursera about Scala. It's like during the whole course, the professor never say anything about efficiency. It's like made me very uncomfortable. It's like he's just like doing a lot of things that it's like he does not worry about the efficiency. And then realize that those language that is designed given like using the functional programming paradigm, they already do a lot of like optimization as long as you follow those functional programming paradigm. So in this way, you don't need to worry about the data efficiency, but you just need to worry about the correctness of the problem and how to decompose the problem in a way that is very readable. And here's basically my current, at this phase, my current understanding towards functional programming. If,
So I don't know if you know the answer to this, because you said you were going to talk about functional programming languages, but like Python itself is used in a lot of cases in a very like functional way, right? So is there like a benefit to like using Python in a functional way? Just like, you know, from a language perspective, you can accomplish the same thing in like a procedural manner.
I doubt that, because I actually asked Eric this question a few months ago. It's like I was complaining. At that time, I was just started to learn functional programming, and I talked to Eric complaining how difficult it is to use functional programming in Python. And Eric told me is that Python is not supposed to use functional programming. And then I went back home and do some research, and then find that the inventor, the author of Python says that when he designed Python, he never think about functional programming. But Python is flexible enough. Like there's some functional programming lover, like how do you say it? Those people just love doing functional programming. They create some library to make it possible to program in Python. Of course, I think because in Python you can pass function around. So Python also natively support higher order function. There's also like a feature, I guess minor feature that borrowed from functional programming that you could say that is kind of like a multi-paradigm. But it's very difficult to do like a pure functional application in Python, in my opinion.
Yeah, I think the reason it got popular Python is popular. Particularly this comprehension support is like this comprehension is just the default way that mathematicians data structures. Making of sets lists as this comprehension makes it very easy to make sense that way. It's the same mathematical comprehension. So that's why it's just popular amongst mathematicians.
It's like Twisted is like functional.
Oh, really?
Yeah.
Oh, I didn't know that.
Function.
Twisted is a functional paradigm, right? For Python.
Asynchronous. This is like asynchronous.
So event-driven. I think the list comprehension is very functional, like programming paradigm-ish. It's like
Yeah, well,
let's say-
it's
say
this
it's-
comprehension is just the way it's just syntactic sugar. Right?
Yeah.
It's just the way
let's say like if someone loves functional programming, you love this is comprehension.
Oh yeah. Well, because it's the same method.
Yeah.
Right?
So first, avoid the iteration. It's an expression, and this is not like to assign to a variable, like in the sum example that we keep mutating the total by keep adding number to it. Like if you are like very extreme functional programmer, that you would hate that instead of mutating something.
Computation is like 3 or 4 times faster than like before.
Oh really?
You do like
You mean for the standard Python implementation or every C Python? So the regular ones are almost the same.
So for loop is slow.
Yeah, you write thing comprehensions much faster than you write that.
Is it also the case for the regular Python? Or the Python that we run on our computers?
Yeah, it's CPython. We all use.
All use C Python.
We all use CPython.
It's like Ruby. It's Ruby.
Oh,
JRuby.
I think default Ruby is mRuby. Because the author is called Mark something. The Japanese name is always M. But default Ruby is mRuby.
CRuby.
Mine is M.
We usually get
Do you know why list comprehension will be faster?
probably optimized. I just noticed that.
Like way they can optimize, they can only optimize list comprehension, but they cannot optimize the loop.
At least I can think of you can have each element
Mhm.
do all the operation at the same time,
Mhm.
and then construct the list return back to you. But in for, it's hard to predict what you will do in for,
Mm.
whether it can be parallelized or not.
Yeah, you probably have to wait for each execution of each iteration that
So you cannot parallelize.
Because also I think it's because Python is like how do you say that? So you will compile while executing that.
Mhm.
So it's almost like
Just in time compile.
yeah, you don't need to compile before on that.
Mhm.
That's also because you cannot do compile time optimization.
Maybe just the list comprehension, it raised some restriction in a way that it let the program know more information in advance, so they can act accordingly. Like better than if flow is too flexible, then you cannot possibly know what would happen beforehand. That's interesting.
probably that also uses it takes advantage of like X range is probably way faster than right?
Mm-hmm.
So that's probably
Mm.
an area in memory.
There's like takeoff is Japan.
Like when you use like 4x in like 4x, like for I equals 0, I plus plus,
Mhm.
etc. You're creating variable I and has to like keep track of that range.
Mhm.
Whereas X range is probably something that just uses
Mhm.
Yeah, they just
Do you have any private repositories?
no. I downloaded the desktop.
Hey, Darian Lee, do you have any question?
No.
Okay, then that's it.
Yeah, and Ruby also compiles to C.
Okay, see you guys.
And Ruby compiles to C.
Yeah.
It's like the lightweight version that author wrote.
Did you access?
Yeah.
I remember writing